what questions do you want to see, do, go over, have questions about? I'm seeing majority 4s, and I saw 1, 1, and 1, 2. So everyone put 1 or 2, and we'll decide on that. So we'll do 2 and 4. Number 1 can be done in decimals. I'm sorry, number 2 can be done in decimals. Number 1 can be double checked in decimals. Using either your capital X, use a different variable, or just using parentheses. So I'm just going to change this to a different variable altogether. This is just to show you that you could change it to a different variable and it would still work. So then this would be 9. So if you got 9, good job. If you use Desmos, make sure you put use Desmos. Questions on that? So then for number 4, that can also be done in decimals or in your calculator. And this is just like your curve of best fit stuff. You're going to use your equation of a line to find your line of best fit. Y1 tilde mx1 plus b. And yeah, that's right. Write 3 decimal places, so 0.847 x minus 10.640. And that would be our line of best fit. I'm going to show you the answers to the Testnav, and if we need to see any of those in Desmos or how we would do those, then we could do that. And then also make sure you have your notes out. Number 1 was D. Number 2 was D. 3 was also D. And then for number 4, there were 3 things you needed to circle. 3x plus 2 and x minus 5. Questions on any of those? One could have been done in Desmos. 2, you could have put them in into Desmos the original and the answer choices with a capital X and saw which decimal match using the slider. 3, you could have put in the quotient and saw which one matched. And then 4, you could have either put in the original and started to put in some of the other ones, saw which one went across the x-axis, or you could have actually did these by hand. 5 was D. And we're going to talk about how to do things with variables today. 6 was C. And 7 was also C. So 6 and 7, you could have put this into the calculator and saw which decimal match. There would have been 2, and you would have looked for which one can't be broken down further. This one, only one of these would work. This one, you could have put X and Y as capital X's and Y's and saw which one matched. There again would have been 2 and saw which one cannot be broken down further. Do we want to see any of those in Desmos? 5 or I'm going to type in the original, but with capital X's and Y's. It's going to try and graph it, and that's not what she wants. I'm going to add in my sliders, change these to something positive other than 1. And then I'm going to put in my answer choices. Attempt to copy and paste this, so this one's in 10. And this was X. This was the same, but this was 6. And 5. And this was 40. Oh, I didn't change that. Right, so looking at the original, I see that there are 2 that match. Not this one, not this one. And between those 2, I'm looking at, on the inside, which of these cannot be broken down more. 20, I know could be broken down to other factors. 5 cannot, so 5, this one will be your answer. Okay. Other questions in Desmos before we move on? Okay. Next Monday, 8 through 14, are due. So make sure you're working on those. If you didn't already, make sure you have your notes out. And go to the page with variables.
Maybe 15 or 14.
So when we have variables, it's really the same thing as what we did on Friday, but you can either use the perfect square rule And I'm going to kind of show you how to think about that with your variables. Or you could expand it and write them out and then find the pairs. And then I'll show both. And then you choose whichever one you feel like is easier. So if m, the exponent, is multiple of 2, use the rule. A to the m over 2. So if whatever underneath the radical, you could divide that exponent by 2, just divide it. And what's going to happen is that's going to become a whole number, and you're going to bring that outside. However, if it's not a multiple of 2, you're going to break it apart. This says the square root of a to the m minus 1, so really find a number that would go into it. So let's say it was 3. You know, 2 goes into 2 once. So I could separate them and say a squared and a to the first, and leave the a to the first inside, but the a squared, I could do that same way. So this one is even number. So I can say this is the same thing as saying x2 to the 2 over 2. And I know this would be 1, so just 1 x would come out. Or you could think about this like there is an invisible 2 with the index and divide it that way. 2 goes into 2 once. Or the last method, you could expand this. I know x squared is x times x. This would be 1 pair of x's that gets to come out. So however you want to view that, do that. Whatever works in your head, do that. Let's do number 3, then we'll come back to number 2. This one is not even. So using this method, I could say, well, I know 4 is a multiple of 2. And separate it like that. And then I know 2 goes into 4 how many times? Twice. So this would just be n squared, and this would stay on the inside of the radical. Or if you broke it into, if you expanded it, I know that would be 5 n's. I have 2 pairs. The 2 pairs would come out, and 1 would stay inside, and then you would just simplify this. So you could do it either way. Questions so far on that before we go back and do 2? So now if you have variables and numbers, you have to think, okay, is this a perfect square? Could I just simplify this, or do I need to break it down and use this rule? So in this case, we get lucky because this is a perfect square and this is even. So if I were to break this down, what would that be? Or simplify it, I should say. 3. Okay, to the power of 5. Because 2 goes into 10 5 times, so it's an even number. If you wanted to break it down, you could also do that. Questions on that? Now let's do number 4, where we have to simplify it more. So first, for the number, do we want to do perfect squares or breaking it down by factors? Okay. So think of the highest perfect square we can divide 40 by. Is that a perfect square?
2.
Is that a perfect square? So you could break it down by factors, which would not be the same thing as using a perfect square. Is 5 a perfect square? 27. So between 1, 4, 9, 16, 25, 36, 4 would be the one that works. Right. And 19 is not even, but I know 18 is. separating it to an even and leaving the one behind. So I know the square root of 4 is 2. This would stay on the inside. The square root of 18, a to the 18th would be a to the 9th. And these two would stay on the inside. So we have 2a to the 9th times the square root of 10a. And once you have numbers and variables, you could put this in your calculator. You could put this into Desmos and check it with a slider. If you put this into your calculator, you can only check the numbers. It won't check the variables.
Does the order matter?
Yes. But of what specifically were you talking about?
I mean, like if you put the square root of 10, 8, and 4.
Yes. This is your coefficient. You want it before your radical. Let's do 5. Is 25 a perfect square? Yes. So that's just going to be a number. We have something that's even, so again, that's just going to break down. This I'm going to separate into two things. What two things could I separate that into? Y to the 12 and this y. So the square root of 25 is
5.
5. The square root of x to the 6, x to the 3rd. And then what would the square root, of y to the 12th, there's so many numbers in my mouth, it's moving faster than my brain. Y to the 6. And then the square root of y would stay. Questions on that? Let's skip a few. Let's do some of these bigger ones. There's number 9. Perfect squares or breaking this down. Okay, so look at your perfect squares, see which one you could divide 320 by, the highest one. 12. 12 isn't a perfect square. What did you say? So use your calculator, start dividing by your perfect squares. See which one would work. 64 and. So we have the 8 on the outside already. Don't lose that. And then, could we simplify the square root of x anymore? No. So that one's going to just stay on the inside. And then we have the square root of y to the 4th. So, breaking things down, the square root of 64 is 8. That would stay the square root of 5. That would stay the square root of x. The square root of y to the 4th, y squared. And then I'm going to rearrange. 8 times 8 would give us 64. Y squared has to come out front. Underneath the square root, 5x. Any questions on that? Let's do one more on this page. 11 or 12? Just to use it. 12. I'm just going to separate everything first, and then we'll talk about separating things more. Is the square root of 144 a perfect square? Yes. 12. Okay. X to the 16th, what would that be? The square root of it. X to the 8th. What about the square root of y to the 10th? Y to the 5th. Z to the 7th. You could break that down or do it in your head. I know it's not even, so one's going to be left inside. And then there would be 6 left, but we're still taking the square root of that, so if we break that down, what would that be? So putting that all together, multiply negative 5 and 12, negative 60, x to the 8th, y to the 5th, z to the 3rd, times the square root of z. So once you know the rule and can apply it, it starts to make more sense. You can do this with any amount of variables and numbers. Do you have any questions on that problem? Are there any others on this page we want to see or do before we go on to the cube groups? Yes. All right, then go on to the next page. And now we're going to do the same thing, but we have to think groups of 3 or perfect cubes. So the rule is kind of the same. If it's a multiple of 3, we can say a to the m divided by 3. And then if it's not, we want to break it apart. That might be 1 left inside, it might be 2. It really depends. So I'm just going to skip 13 and go on to 14. Is 64 a perfect cube? Not a perfect square, but a perfect cube. Yes. I'm going to break this down first because I'm going to do that first. That will give us 4. Is 9 a multiple of 3? Yes. So this would become what? M to the 3rd.
So the square root just disappears.
The cube root, but yes. Because if I broke this down, that would be 4 times 4 times 4. The group of 4s would come out of this. But in 15, is 7 a multiple of 3? No. So you can think about 3 would go into 7 how many times? 2. So I'm going to change that to the cube root of p multiplied. 3 times 2 would be 6. And then leave that one off. That would be a great way to break it down. Or again, you could list them out, expand them. So then 3 goes into 6 twice. This would be p squared. Oops, this was supposed to be 1. Sorry, not 7. And then this would stay the same. If you want to put parentheses in there so your exponents aren't getting confused or mushed together, you could do that. You don't need them. Let's try something bigger, 17. Actually, I think that's a perfect cube. Let's try 16 instead. I'm going to separate everything. Is 40 a perfect cube? No. So figure out what the highest perfect cube that goes into 40 is. Negative 3 times the cube root of 8, and the other one would be 5. 3 goes into 16 how many times? Or think of the closest factor that 3 would go into. So it would go in 5 times with 1 left over. Then breaking everything down, the cube root of 8 is what? 2. This would stay the same. The cube root of w to the 15th. Divide 15 by 3. W to the 5th, and then this will stay the same. I ran out of space. I'm going to write this over here. So then everything on the outside, we have negative 6 w to the 5th times the cube root of 5w. Let's try 18. I'm going to bring the negative out first, and then break everything down. Is 250 a perfect cube? No. Find the highest perfect cube that would go into 250. And 125 times what would give us 250? 2. 3 goes into 3 once, so that would be a perfect cube term. 3 goes into 4, how many times? Once, and there'll be 1 left over. So I'm going to write that as, it would be, so if you wanted to actually split it up as the cube root of 3b to the 3rd and the cube root of b, you could do that before doing this, or you would know that 3 goes into 4 once with 1 left over. So what all would be on the outside? Negative 2ab. Oh, I forgot to do this part. My bad. The cube root of 125 is what? 5. So that would also go on the outside. It would be negative. I was just writing out all the steps. Negative 10 AB times the cube root of 2. This part? This 2 and this B. Okay, so we're going to stop there. We'll do one of these as like a warm-up tomorrow before we go into our next thing. I know we went through that fast, so if there's something you're not understanding, please come see me tomorrow, ask questions during the last bit of class. Reminder, you do have adjust math on this that's due on Friday. You have SOL practice, J-Labs, past skills math,